Hi, folks. Thanks for coming. I'm Sherri Adame. I work at General Motors. I started within their software-defined vehicle space, where I defined a vision for data governance, and then took on a role for their enterprise data governance team. And that's where I sit today. And I'm leading the team through like an end-to-end implementation for data governance. And this is one of our key experts as well.
Thank you, Sherri. My name is JP. I have roughly about 15 to 17 years of overall IT experience. Over the last 7 years, though, my primary focus has been in data governance, and the last 2.5 years really specialized in data access. So it's nice to meet everyone.
Yep. Thanks for coming. We know you guys are like the true data people at this Databricks conference, so I'm going to memorize all your faces, right? And I'm the kind of person that thinks like there are data people and there are people that are not data people. Like it's quite black and white to me, actually. So this is the Databricks forward-looking statement piece. Don't forget to complete your surveys, and then let's get right to it and talk about how we're shifting left on data governance at GM. So when we started, we said, okay, the corporate data philosophy is really around how do we get things faster to market and do it in a governed way. And really, when we think about faster to market and agility, when we looked at the data culture within GM, it lagged behind. So if you think about GM as this huge organization, there are teams on the spectrum of data maturity. So how do you crack that nut? We came up with 3 things to focus on. One, we wanted to shift left. So insert governance at the beginning of the development lifecycle. So our team sits within the engineering space. So we partner directly with the engineers and put in some processes, and I'll describe what those are. We also wanted to shift from being reactive to being proactive. So long gone are the days of, oh, you've delivered this to production? What's the definition for that? Should we put some quality rules on it? How should we protect it, right? We're gonna have all those conversations up front so that when it deploys in production, we have the policies in place. And then we have the shift from big data to domain data. I won't spend a lot of time on that. I think if you're here at the Databricks conference, you are already shifting probably from big data sets to a more curated approach to delivering data products. So when we think about governing from design, I talked about us sitting in the engineering space. We play a role, data governance plays a role between strategy and analytics and data operations in the data platform. We partner very closely with the operations teams and the platform teams to make sure we understand what the data is, and it gets registered in our catalog and classified, and we understand lineage around it and all of that, so we can do governance by design. But we also play a role with our legal cybersecurity teams, as well as the privacy teams, to understand what's the strategy and approach, what's our perspective or point of view we take on our data. And then we, of course, work with the analytics teams that consume the data from the platforms. So we have 5 core principles. So everything that our team does really focuses on these things. 1, we want everything to be proactive, automated, and adaptable. It can't be an inflexible thing that you can only use with one data set or one data type. It needs to be able to be used across all kinds of data. We also want our data to be easy to discover, understand, and use. So that's a hard thing to do, but we have deployed our Atlan catalog to inventory everything within our Databricks environments and pull it in. We're currently focused now on partnering with our Snowflake teams to pull in their data sets. And we started conversations just in the last 2 weeks to talk to the folks that use Google Cloud and pull in their metadata as well, so that data from across the organization is easy to discover. The understand piece is difficult. So because we're in the engineering space, we have a really good handle on what's happening from an engineering perspective, so the technical perspective on the data, but the contextual understanding of what that data is and how to use it has been a tough nut to crack. So if you feel like that's something you're excelling at your organization, please find me because we're still working on that. We have a lot of metadata and we're enriching it. We score our metadata. We have policies that we deploy automatically. But this conversation with who is the business steward for us, because we're embedded in engineering, is we're working on that now. Like we're going full force on that, figuring that out. At our place, we have a product management team, and it's the product management team that are defining these things, and they really are insulating us from who those business resources are that we need to be getting into our catalog. So that's something we're working on today. Data governance must also meet security, legal, and compliance considerations. So we have regular forums with our legal and cyber teams where we talk through what their requirements are, and then we reflect it in practical approaches that we've deployed in our framework. We also committed to monitoring data usage. So every piece of data that you have out in a production environment carries an amount of risk. If you have a piece of data that's out there that's not being used or not being used as it was originally intended, like our push is to bring that transparency to the usage piece, not only by people, but by systems or applications, and then push to have those things shut down that are not delivering value. So we have a set of usage reports that we're deploying where we look at all the data across Databricks and look at the usage on that, and then present like what's being highly used to what's not being used. And then the last piece is we have structured standards for metadata where we have YAML files, protobuf files that we collect from services and applications. We ingest that information and pull it in a structured way, and we can understand data ownership right from the inception when it's being released to a production environment. We register data transfer, so any transfers that are coming in from external third parties or transfers that are going out to external third parties, we register those things and we put a weighting or risk on them as well. And then we're going down the AI path full force. So right now we have an AI governance POC where we're collecting a structured set of metadata. We'll collect it from GitHub in a structured YAML file. We'll snap our data catalog Atlan to it and then ingest and automatically read those models as well. So we're traveling down the AI governance path. So for us, like I said, everything has to be proactive. We're looking at it end to end. We don't want to put just a piece out there. We want to put in that end-to-end process that really helps us understand what's happening with our data sets. And in 5 minutes, be able to say, this is the data, this is how it's being used, who it's being used by, in what country, or by what application in what country as well. So when I look at the technical solutions that we have, so of course, we have accountability and consistency. So we defined a set of processes. We have specific set of roles for stewardship. Like I said, I feel like we've nailed technical stewardship or the data curators. We have very good relationship with them, and we're really exploiting the value of that. Now we're forging down the path of how do we push back further left and get into the business's head to understand the context of our data better. And the technical solutions we put in place is metadata management. We have an internally custom developed metadata repository that allows us to connect directly to our GitHub environment and protect our code bases. That way it's like a layer in between all these third-party tools that we're using. So we can collect protobuf files, YAML files, JSON files, ingest those directly from release branches in GitHub, parse it, rationalize it, and then expose it out to the data catalog. We also use, I'll go to the bottom one, data classification. That allows us to, once we get the metadata in that's going to be released to production, we classify it with a utility that's platform agnostic. It's actually going to release on June 30th. We're in the final bits of testing on that. We worked with the audit team as well as our privacy and compliance team to make sure that we're classifying appropriately according to our standards, and that we're putting that out for all production data, because we had an aggressive OKR goal this year to say that 95% of the privacy-related data would be classified as so, and 100% of the metadata for those things that are classified as PI data would be enriched, or the metadata would exist for that. So I think we're gonna make it. Fingers crossed. Check with me again in November. I'll tell you how it went, but we're releasing that to production. So those are kind of like the front end of things. We have a data quality platform, Anomalo, that we purchased. It allows us to detect anomalies on our data and then reflect that information back out to our Atlan catalog, as well as allow our engineering teams to build complex rules within that tool. Our data catalog is Atlan, as I said. Data lineage is also brought into Atlan. When I started on this journey, we spent a lot of time having to answer, why are you bringing in Atlan if there's Unity catalog? And so what we did when we talked through that was we really wanted to have a catalog of catalogs, right? Because we have all three major cloud platforms, we wanted a catalog that would allow us to look at metadata across all these things. And we felt like the search functionality in the Atlan catalog was better than the search functionality in Unity catalog. And we did time studies against that. And what we found, it was 6 times faster to use Atlan to search and find the same information that you would find if you were searching in Unity catalog. So you can use Unity catalog, but if you have a really big, complex environment, you may want to consider using something that can really address that complexity in what we feel like is a more complete way. And then the last piece is data access. So today, when we first started, now 2 years ago, everything was on-prem. They had Ranger policies, and there were thousands of them, and nobody quite knew what those Ranger policies were doing. So one of the first tools that we selected was Immuta that allows us to deploy data policies. And JP is going to talk about this in detail, so I won't steal the thunder, but a very few data policies for the huge, vast sets of data that we have. So we're on the journey with data access, and JP is like his thing, and we'll talk about how that works within the framework itself. And then, so when we think about where do we fit in with interactions with our organization, so if you think this is just typical like build cycle, right? There's a business need and a go, no-go decision. So when it gets to development, that's where we kick in. We have our first interaction where we're saying, hey, here's the definition of ready for the epics or features that you have that include data. So we describe to the product management team the acceptance criteria that needs to be in those features, or actually in the epics, and then the engineering teams pick up and create the features so that they know what to build against. And we tell them what the expectation is at the get-go. And then we go through a certification process. So while they're testing, after they've tested, they'll be deploying a YAML file or a protobuf file or a JSON file to a release branch. We'll automatically pick it up and certify it and provide some feedback on that file. If there's metadata in there that's not complete, we will reflect out to them what the errors are and what standards they have to meet, and they resubmit. It's just like a regular operation now. And then, it eventually gets released into production, and then we get to data use. By the time we get to data use, we're set up because we've collected the metadata up front. We understand what's being released into production. We've understood what the classification of the data is, and the policies have been written. Now, when the data hits production, we're in a protected or governed state. And that's where I leave off. And JP will talk to us about designing for trust.
All right, thank you. All right, so let's just go ahead and get started and jump right into it. I think Sherri, like she's mentioned a lot about shifting left. And so this idea of shifting data security left is what I will discuss, right? But let's first just start off with some of the challenges and to give you guys historical context here, right? So like 2.5 years ago or 2 years ago when Sherri and I started, like security was basically an afterthought, right? Which led to very slow data access. And what I mean by that is that from an engineering standpoint, their main goal and idea is to create data or land data that would essentially support data processes or some sort of application or business processes, right? And so what would happen then, that would lead to a bunch of tables that exist in this schema structure that will have a mixed bag of or levels of data access, which would lead us to manual controls, which obviously those manual controls do not scale. And so with that being said, now you have this picture of like these three components that are not connected, right? So like you have engineers, you have a security aspect, and you also have a data access component to this. Okay, so our idea, right, is in shifting data security to the left. It primarily evolves around having upfront conversations with our development teams regarding security, data security, having them really start to think about, who's going to be accessing your data, what sensitive data will you be storing, and being able to create those clean boundaries or clean schema boundaries so that we can then begin to automate and enforce data access policies. Okay, so just to dive a little bit deeper into some of those components, so tag, sync, and enforce. So as Sherri alluded to, we purchased Atlan as our primary data catalog, which is essentially used for storing our metadata as well as our source of truth. And so our data stewards will then go into Atlan, tag the data that's based on their security posture, and then those tags would essentially sync to Immuta, which is our data security platform, where policies will be, where we apply policies automatically based on the tags and attributes assigned to our data sources and users and groups. So one thing to call out here, the only thing that's manual today is the attributes on the users and groups. Everything else is basically automated today. Next, we get into designing for purpose and sensitivity. So we've worked with our engineering teams, like Sherri showed you guys on that one diagram, exactly where data governance inserts itself, which is in the upfront, the development part of it. So our data governance team today, we play a critical role in schemas being created. So upfront, we're asking the engineers, okay, so what type of sensitive data are you storing? Where does that data exist? Who needs access to that data? As well as documenting that business purpose. And so I think one thing I really failed to mention at the beginning was that regarding like the manual process for granting data access to these tables, we wanted to really roll that up a level and look at data access from a schema level. And so the main way and the only way for us to do that was to create those clean schema boundaries to support those automated policies. So here it just gives you guys an overview of how our access request workflow looks like today. So we operate using SailPoint. And SailPoint is essentially like this air traffic controller, right, that is going to direct traffic to the appropriate approver. So a user goes into the system, requests access to a specific role. That role will then get routed to an approver for a decision to be made. Once the approver approves it, if I could think of a better word for that, Then that user then gets added to the appropriate AD group where they're scanned and synced into our Immuta tool where the access will be granted to those groups based on the attributes applied to those groups there. I am speeding and rushing right through this thing. Let's see. Okay, so just very quickly how our attribute-based policies work. So this is a screenshot of what an Immuta policy looks like today. So we utilize their advanced DSL here, where we were able to call this function called has attributes. And essentially what this says is that it's going to look for a variable called allowed tables on a group or a user. And then followed by that are the specific values that will be stored in that variable called allowed tables. And so for us, it was very critical that we do not manage access at the table level, because what that would mean is we would have to list out literally every single table that group would have access to. And so part of it, again, just going back to having those upfront conversations and tough conversations with the engineers, just designing an approach where we could deploy access at the schema level. So in this case, how we would do that is we would list out the database or catalog, followed by the dot, and then we'll reference the schema that they'll need access to. And then in order for them to gain access to all tables within that catalog and schema, it'll be a star. And so the other cool thing about this Immuta policy is that you can write it at any level of granularity. So if you wanted to grant access to all catalogs or all schemas within that catalog, it will be catalog.star.star, or all tables within that schema, catalog.schema.star, or you can go to a more painful route and list out table by table here. So the other cool thing about this is that along this journey of data access, we were able to simplify the number of policies that we wanted to deploy. So we're in a data mesh model, right, where we've broken up big data into domains. And so you could essentially roll out one data access policy to control all of your data, because how you'll restrict the data access is simply by referencing the database structure there, or you can assign a policy per domain like we've chosen to do here. And so what we've done is created a auditable structure and repeatable process for administering data access, whereas in the past, in this reactive approach here, data access was just all over the place, right? So like you can receive email requests for data access, or they could follow a process, or if your friend was the owner of a schema or table that you needed access to, you could just go over to them and tap them on the shoulder. Okay, and I'm actually nearing the end of this thing. So pretty much, I just wanted to put a quote up here, right? Just to reiterate the idea behind security, right? And so like most times when we think about data security, it's like an afterthought, right? Like that final step in this process after you've done all your work. But really what we have to do is we have to be proactive in our approach to security by having those conversations up front with our data engineers, involving our data stewards, and creating a policy so that trust then becomes scalable, right? And so like part of this process of doing this upfront work was that you're now just managing the exceptions here, right? So like if you can imagine being able to separate your sensitive versus your non-sensitive data, or the different levels of data access, then you can pretty much just democratize that data set, right? By auto-approving, which is what we do now for a lot of our roles. We auto-approve our 80% of the data and then manage the 20% by way of Immuta as well. So just being able to just to have those upfront conversations with the data engineers, understanding what data they're creating, that they're working with, who should have access to it, allows you to build a much more scalable and robust process here. And then finally, what we've achieved, and we still have a long ways to go here, but really one of our main objectives, besides just making data access easier, was to be able to answer who has access to our data sets and why. If you can imagine, right, like coming from that manual process, it's very difficult to determine who has access to your data in a timely manner or reasonable manner. I think we were taking maybe 2 to 3 days to answer that question. Now we're under, 20 minutes or to an hour. I'll just say under an hour today. Access is granted consistently through a centralized policy-driven controls by using Immuta. Immuta really helped out a lot in this space for us just by their design and approach into simplifying the number of policies. Like Sherri had mentioned earlier, we were using Ranger policies to control data access, but now you can simply, with a minimum set of policies, roll out and protect your data in this automated fashion by using those policies there. And then lastly, audits are faster, cleaner, and backed by automated enforcements there. So Unity Catalog has allowed, opened up a lot of those system tables out there for you now to look at, to determine who has access to the data, to your data. Immuta's actually doing some work in that space as well. And I think that's pretty much it. I don't have anything else.
Any questions?
Any questions?